So this is where we left off from last time, and as soon as we finished killing the villagers, that was the end of the project. So now, in case you didn't figure it out last time, we're just gonna head back home. And in this video, we're gonna be heading into our last project of the Minecraft Coding Camp tutorial sessions. And this last project, which is on farming, Project 4 Farming, is a really complicated project in comparison to the other three. And there's a significant jump in the difficulty from Project 3 to Project 4. So to make things simple, especially if you don't have a good coding background or this just got too complicated for you, we're going to split Project 4 into 3 videos to make understanding simpler. So in the first 2 videos, we're not going to be doing any actual coding of our own. We're instead going to be analyzing examples in the project. So let's get into Project 4. And these random swords and stuff that appeared for you, you can just get rid of them. They're not useful. There's bonus things in the game, so you can just press Q to get rid of them, throw them away. So now we've reached the first example here. It says check the program farm, and here we implement the basic tilling system. So before I get started, I want to go over some concepts that we'll be experiencing in Project 4, and some of these include a lot on Concept 3D, which is about conditional execution, and there's a big emphasis on if statements because we're expanding this to nested if statements and also else statements. So we can have if statements inside of if statements and also else statements to provide alternatives to our if statements that we build. Next, we're also going to be looking at Project 3A, number 5, specifically in operations, which introduces the modulus operator, which I'll be discussing further, which is kind of like a remainder operator when you perform division. It gives you the remainder of the division process. And then we're going to also cover 3A overall. We're going to delve further into variables, explore variables more, and do more incrementing stuff. We're going to work on Concept 3B, number 3, more on while loops. And there's a big emphasis on Concept 3E, which is on utility, because this project is completely based on farming, and it's unlike the other projects where we're directly interacting more with actual real-world applications, because here we have to combine a lot of concepts, as we'll see, like planting, like tilling, growing the crops, then harvesting the crops. So, and this deals with a lot of actual real world materials such as seeds and fertilizer. So this connects more to how programming is useful in the real world. So let's get into what this first turtle here does. So it says check out the farm program. So we'll edit farm. And you'll probably notice this is quite a long program. This is in fact 73 lines long, so it's going to take us a while to analyze this. So it says define farm dimensions. So it says rows equals 9, columns equals 5. That should be pretty straightforward. So our problem basically here is to till this block of land here in this enclosure, and they already pre-measured the dimensions for us, which is 5 by 9. So now we're going to be so we're basically using a program to track our current position, and using our current position, telling the turtle when to rotate and when to move on to the next row, when to move on to the next column, etc. So as a result, we have these other two variables to track our position called current row and current column. So thinking of the area that we're tilling as an array, like an array as in like a square or a rectangle, you might have made arrays with those. Just like that, we're looking at each block as having a unique row and column number. So now we're getting to the actual program. So the first thing is turtle select one, turtle refuel, which is standard for the beginning of everything. Then the turtle moves forward, and then this turtle.dig down function is what essentially tills the farm, tills the land, because it removes this green layer and exposes the dirt underneath. So that's what turtle.dig down does. So this is the first part, and it's essential. It just makes us move away from this water area and onto the first block of land and retill that. Then we have the while loop that that carries on for while current column is less than number of columns. So essentially, this process will continue until we've gone through all the columns. And then we have inside another nested while loop. So here's our nesting concept, and each column is operated on for each and every row. So the big loop will continue for all the columns, and inside each column there'll be a repetition for each row. So while current rows less than rows, turtle forward and turtle dig down. So for each, so as the turtle's advancing rows, it's gonna dig down. So basically, what's happening is, we're gonna start the first column, we're gonna dig every single row, move to the next column, dig every single row, etc. So that's what these two loops are doing here. Then we see current row equals current row plus 1, which is an incrementing function because we need to know when to end this while loop and move on to the next row in the current column. Then rotate right, because what this part does is, the problem you see here is when the turtle gets to end, you have to turn right, and when you get over here, you have to know how many times to turn right additionally. So we need to have these turn right functions. So if column %2 equal 1, that percent is the modulus operator we talked about earlier. Essentially what it's saying is, if the current column divided by 2 leaves a remainder of 1, then do this. The reason this makes sense, would make sense to you, is that dividing by 2 and having a remainder means the current column is odd. So it means if you're an odd column, then it's going to turn right. So it means this only works for columns 1, 3, and 5. 1, 3, and 5. So if we're on columns 1, 3, or 5, and when we reach the end of the end of the row, when we finish all of the rows, we're going to turn right, go forward and dig, and then turn right again. So now we're going to be coming towards the fence here. So we're going to be moving this way. So that's turn right. And then if we're on an even column, then we have to turn the opposite way, because turning right will be for the odd and turning left will be for the even, because you have to go this way. So if the row is if the column is even, then we're going to be turning left, going forward, and turning left. If that makes sense to you, because if we're going forward this way, we turn right to come here. Then if we're facing forward this way, then we turn left to turn right here and keep going straight that way. And then x equals x plus 1. We'll go into further what the x does afterwards. And incrementing the column and resetting the current row, because we have to reset a current row to get to work on the next column afterwards. Now, after we've finished those two while loops, we should end up around there. So now the next part of the problem is to get back to original position. Well, that's not as important in the problems such as tilling. In the next few projects, that kind of concept of moving back to original position is important, so that we can pick up the next material and keep working. So to move back to our next position, to original position, while we make two more variables, moving back row and moving back column. So these are variables to basically backtrack everything we've done. And while moving back rows less than 9, do turtle move forward, turtle back row equals back row plus 1. Basically, we're going to keep moving down this way until we finish all of the rows. And then we're going to move sideways this way until we finish all the columns. So that's this next part here, which is by moving back column being less than 5, and then moving forward for each one. And then the turtle turns right, so it's repositioned in the proper way. And that's how this code works. So now let's try it out and see how it runs. So let's type farm. So you'll notice here, since we're in an odd column, it turned right twice. And now that we're in an even column, the turtle is going to turn left instead of turning right. And you can see like the in-game animations that make this more of a real-world problem, in that the water is like fertilizing the ground now, and the ground is ready to be like planted. So that's basically what we're going to be working on in the next few projects soon. We're going to actually plant stuff and then harvest it. So you can see how the moving back row and moving back column variables work here to bring it back to original position. So now let's look at the next turtle here. So here we're adding in seed plantings. That's the next part of it. So we have to, in this time we have to the turtle not only till, but then also plant the seeds afterwards. So let's look at this program. So edit farm. So we see the same sort of program as the previous one, which allows us to similar kind of the one as the previous one, in that we're still using the same kind of row and column logic. The only difference this time is before we start, we use this thing called turtle.suckdown 45, which suck down means to draw 45 things from this box, and we've selected 2, so 45 things in inventory slot 2, which is actually corresponding to the previous one, because select 1 is like a standard for refueling. So it selects it in the first one here, which is actually 45 seeds. So that lets us draw out those 45 seeds. So now, after, just like before, we have a turtle.forward, turtle dig down, but then we add two additional functions to select the seeds and then place the seeds down, because that's the planting portion of this. And then similarly in all of this, just through the while loops, as we till the ground, after every single function that makes the turtle dig in the ground, we're also doing a place down function. So that allows the turtle to also plant the seeds immediately after digging the ground. And then we're doing the same sort of incrementing, same rotation logic as before. And we're also having this incrementing of the column to finish our columns. And then the same logic with moving back. So the whole logic stays the same with planting the seeds, but this time we're just adding in a feature after every single dig function, which plants the seeds instead of just digging. So let's see how this code works. So we notice that after each dig, the turtle is also planting seeds directly in. So we can see how that code works, because we're just adding an extra feature to every single loop. We'll just let this go through. So just like a farmer would do in a real world problem, we planted our seeds. So that's all we'll be covering for this video. If any of the concepts were unclear about the while loops, I'll be going over them briefly again in the next video. So, but I highly recommend you rewatch, like especially this part in the first farming utility we did here, so you can get a better understanding of how this worked. Make sure you take note of all the nesting loops we did, the logic we did inside each loop with incrementing, because there's multiple incrementing in a given loop, one that does an inner loop and one does an outer loop. So make sure you pay careful attention to those kinds of things, especially dealing with complicated problems like this. And in the upcoming videos, we're going to be going over more advanced concepts like fertilizing, which is actually not that advanced, but then we're also going to be going over harvesting. So that's all for this video. Thank you.